Okay, and actually, I'm Jerry Zhao. So I'm the chief SDV architect from the Panasonic Automotive Systems in Japan. I'm also the leader of AGL SDV Expert Group, which AGL has been just introduced a lot from Yamaguchi-san. So another page is that I actually after I was born in Tianjin, China, and I went to Hong Kong University in 2012, and after graduate, I went to Japan directly for work, and have joined Panasonic for around 8 years. So it's quite long when you're considering. I mean, especially the non-Japanese employee. So actually, in my third year in the company, I became the AGL SDV leader. So, previously was called Virtualization Expert Group, but this kind of expert group has been extended and had more roles in nowadays, and we rename it SDV Expert Group since 2023, I guess. Besides AGL, I'm also the SOFI APAC Regional Hub Chair since this year. So although in this session I will not talk a lot about SOFI, but if you have some questions, maybe in the follow-up sessions you can raise your hand. Regarding today's agenda, so this is the major four topics I will cover. So first, what is the trend of the software-defined vehicle, and the second one, what kind of open ecosystem are there in the automotive field? So who is working towards SDV? The third one, so we will focus on the AGL activities and how this kind of code-first community can really help to realize SDV. And the last thing is to be talking about future AGL perspective, and not only the AGL, but there's, we mentioned in the second part, there's a lot of open ecosystem for SDV. So this kind of inter-community connections will be very important. So let's go to the first part. So first, I will actually ask everyone to think about what is the software-defined, or in Chinese, 软体主导型. Actually, it is very interesting topics, and let me give some examples in my daily life. Is that actually I changed my rent room since last November in Japan, and maybe not like in Taiwan. Japan, especially Tokyo, has a really small apartment. So originally I was living in a 30 square meter little house, and now I moved a bigger one, which is actually 80 square meter. So the new questions will be, in the past, I can just move the rooms by myself, but it's now 80 square meters, and it's quite large, and the work, and especially the AGL activities, is always happening in the midnight, so I cannot clean my room. And how should I do? First, I came up maybe just buy something by Dyson, or even my company Panasonic's vacuum cleaner, but it still actually didn't solve my pain that I don't have time to do this everything by myself. And latterly, I actually bought this a robot vacuum, which is very convenient that you actually set up everything through your applications on the mobile, and you can set up the load and the clean mode of the robot vacuum so that it can really do all the jobs by itself. And it's embedded with a powerful AI, which you can the machine can detect the dirt, and also the spaces that's not easy to clean, and using some special mode to clean up those things. and this actually really saved my life and make my room very clean almost every day. Another need is that actually I started to raise a cat after moving to this room. The question is that still I need to work, and sometimes like now I need to travel overseas. Then the question is that how to feed my new cat. So there's some machines, pet feeders, which use the mechanical or button or pressure sensors that maybe you can set up some timer so that periodically it can release some food. But that is not smart enough, right? So I bought some smart pet feeder. So it's a quite digital things with application control that you can again you can set up everything on your mobile to connect this pet feeders and set up this pet feeder to feed your cat food or water, and you can also probably using actually some sensors to detect the pet health status and to adjust for example, temperature of water or the volume of the pet food. So what's the difference of this left-hand side and right-hand side? I actually I put it in this way. The left-hand side is hardware or mechanical defined, which is you have fixed functionality, so one-time cell. But on the other hand, the right-hand side is a more like a software defined, always updating, continuous subscription. So for example, for all this kind of global version and smart pet feeders, actually every maybe 2 weeks there's some new release for the applications or even the firmware of the hardware, and it's also adding some fancy features and request you to subscribe. For example, they have a vlog for the pets, and so that you need to pay for the vlog to get the full access of all the videos. Otherwise, you will only have a 7-day storage limitation. But anyway, this is actually the transformation of hardware mechanical defined to the software defined, which actually indicates a general trend which is showing on this page. And we look at from the history perspective that in the past, in 1960 something, there is the very huge servers from IBM. The mainframe is over there. Although the compute power is very low, but the space is quite huge. And you also have feature phone, and I think in China, in Taiwan, it is called Dagada, and the watch is invented. It was invented in 1930 or something, and all these kind of things, actually product value is defined by the hardware and mechanical. But when we come into the era of 2000, and we gradually having this kind of a new update. For example, the computer has become the Node PC, which you can, which is not only the PC itself, but the applications on the top of it, enabling you to play games, enable you to work and to entertain, to develop your hobby. And definitely for the feature phone, there's a huge transformation from the Apple, and also at that time I think the HTC have had a great update that moving all these things from PC to the smartphone, that we can use our smartphone to do almost everything we have did on the Node PC. And later on, the smartwatch is coming up, and it is not only the typical watch that we only check time, but it helps us to monitor our health, or our sleep status, those kind of things. So all the right-hand side products actually all the values was defined by software. So actually, it's not only the software-defined vehicle or say SDV. It's a overall trend of SDX, which is the software-defined everything. Starting from PC, various devices has become intelligent thanks to the evolution of software. So this, with all this background, it comes to the software-defined vehicle that we have more features in the future vehicles. For example, the comfort cabin UX, so that you probably have more powerful displays, which are more advanced HMI experience. And you also have realized that ADAS or AD is not only the level 2 plus, but even autonomous driving upper than, greater than level 4, for example. And not only for the cockpit and the ADAS domain, for overall the vehicles need a timely, continuous involved functionality. So from this kind of OTA perspective, you need to add functionality periodically and fit your customer's needs. Actually, I integrate the SDV, software-defined vehicles, in another way. It's called speedily delivered values. I have talked about SDX in the previous page and also the SDV. And let's look at some data. So we have some data from the internet that, for example, for this Note PC, it's a 50 million line of codes. For smartphone, it's 12 million line of codes. And for smartwatch, if it is Android, which actually is a little bit large, for 10 to 12 million. LOC, if it is Linux or other systems, maybe a little bit smaller. But this is the level of the traditional portable devices. But when we look at the vehicle, actually according to some research data, in 2030 it will becomes 6 billion lines of code. And I think that that time the information was not counted the impact from AI or generative AI. So if it is if we take the AI implementations into account, it's probably even more. So why the vehicles need to have so many codes? Because you need to integrate every this kind of functionality. Actually, this is all of this system is something equal to each this kind of smart devices. And you need to integrate all these kind of things in your vehicle so that overall the vehicle has become the most challengeable software development in the world. So, to solve this very huge system, can we only, for example, ask your developers to work hard, to work until very late, or just to employ more employers to ask them to work hard and so this kind of a traditional way that in the manufacturing companies always use to add efficiency or add more people. So with the level of the volume of the softwares in the right hand side, this kind of traditional way may take some effect a little bit, but it's not enough. So what we really need to think is how to increase the efficiency more smarter. So we need to really have some more architecture improvement to make our architectures more portable, more scalable, more modular to reuse across the different variants and generations. We need to the things, but the whole ecosystem to work together for those kind of non-differentiating areas. So this actually comes to our today's, this SDV tracks focus is about how ecosystem is helping to enabling SDV. So let's go to the second part, so open ecosystem for SDV. I think I'm a little bit running out of time. So for this, so let me put it very simple is that there are majorly globally five major organizations is working something around the SDV. Um, and they have different natures. And for the open community, actually I can summarize it in this way. There's a open source community and open standard community. So I don't think either of them is good or not, but it's the different natures. Because for example, for open source, you really have to everything to be open and everyone can access it and use it. But drawback is that some commercial vendors will be not involved into that game and to develop their proprietary software by themselves. But for the open standard, although sometimes there's no code, there's no this kind of compliant or say strict rules for people to use the same code. It is only defined some standards or some interfaces or some requirements for companies to implement. So although there's a drawback from the accessibility or say the publicity, the benefit is that some commercial vendors or some proprietary solutions vendors can also join into this kind of game that they can share the same commonality with the open source software. So all this kind of thing I think is beneficial also for the overall open ecosystem. And with this kind of concept, there are different organizations working on different topics. So I just simply give some categorization. For Autodesk, it's more focused on the open standard. So they have a very huge of requirements and specifications defined, especially for their passage Autodesk. It's more focused on safety and reliability, especially the ECU control to control this kind of peripheral devices. So it defines standard framework and EE architecture, although they don't have a much touch in the real source code. For Covesa, so this is something interesting that in the past maybe it's called Genevieve, and it also doesn't produce a lot of code, although some reference implementation was provided there. But for example, for recently, they also focus a lot of activities on SDVs, including one of the vehicle signal specification VSS. So this kind of specification was widely used in a lot of open communities and even commercial products. SOPI, which is maybe the newest community among all these communities, is actually set up around 3 years ago. Its objective is to create a cloud-native platform so that you can develop your software in the virtual environment on the cloud and then deploy the same software to the embedded hardware. So actually, I think this concept was originally coming from the server world, but nowadays it's more common and popular in the automotive field. So someone call it a cloud native, someone call it a digital twin. It depends on your context. But this kind of concept has been really becoming more popular. And for SOPI, although originally it's more like a open source standard organization, but recently they changed the directions to introduction. Also, I also tried some magics with the generative AI. I used ChatGPT to ask him because the order of this organization, open organization, the ChatGPT has the access to all this kind of public contents. I asked the ChatGPT to create some icon that summarize the feature of this communities. Actually, it did a very good job. For example, authors like the ChatGPT understand is targeting for the ECU, and actually the architecture is in this way with application and this kind of runtime extension and the base software. Exactly the author's architecture. For Covesa, because probably in my profile I give the VSS, he gives some this kind of signal related icons, and also some interesting is that this is not code but it's more like a documentation. For Sophie, it also gets the feature of the cloud native to develop your softwares on the cloud and then deploy to the edge. For Eclipse SDV, so it's for both cloud and car, the safety is the important things that they are tracing. And for AGL, you can see this mark with the coding. It's exactly the code first principles that AGL has working on this kind of IVI and Mater. This is exactly summarize what those kind of organizations are doing. So we're probably giving a more focus on the AGR related topics for your background before entering some detailed discussions in terms of AGR from my colleagues. So before going to the detailed topics, and I will give this kind of commonality on what kind of things that the overall automotive industries is working. And I mentioned that from the hardware defined to the industry has evolved to the software defined. And when we're coming back to the development styles, so it's also the development was coming from was transition from the hardware first to the software first. In the past, we actually, if we have the idea, we implement the hardware first, and before this hardware is ready, we cannot do any software development. Or we can do some kind of software development, but need to rework after the real hardware is launched. So this is really time consuming, and each of your team member have really hardware limitations for the hardware. And nowadays we call it the software first, or say the cloud enabled architecture, so that we can have the same software working on the virtual hardware and the automotive hardware, so that you can develop your software first on the cloud continuously, evolve this software, and on the optimal timing, you select or develop a hardware and launch the same software onto the same hardware. So it's having much faster value discovery and the introduction to the market. And let's come into another background. So the previous page is more about the development style of what's happening in the automotive field. And this page, so let me first talking about the generic history trend of the computing architecture of the server board is that in the first is the distribution. It's more like you have individual servers, and later on people think this is not efficient. They somehow centralize the hardware and to have some powerful OS or hypervisors to do that. And after that they found there's a lot of overhead in this kind of system with the full virtualization, and they again to distribute the software. But later on, some more, for example, the power virtualization or even the hardware assisted virtualization was implemented, and people coming back to the centralization. And after 2000, it's like a more hybrid approach that you have both the centralized and the decentralized architectures using the orchestrator to have the hypervisor and the containers used together. Um, so actually, we can think that the generative computing architecture is repeating this kind of cycle between the centralization and the distribution, and exactly, I think the automotive world is now here and transiting to here. So you can see how to so alongside the history, there's always a big topic as to how to decouple the software and hardware, and this is exactly the things that the server world and other industries has been already struggled. So what we really need is two important parts. One is to decouple the operating system from the hardware. So it's called hardware agnostic virtualization framework. And we also need to decouple the applications from the operating system, which is OS agnostic application framework. So not only for AGL, but also a lot of open source community actually is working on both this kind of sides for different scenario or use cases. So not only this kind of hardware architectures, but we really need to have to consider more logical architectures to do this kind of decouplings from the underlying layers. And so, you know, the importance we discussed speedily deliver values is really that you can advance your software more rapidly. Uh, those kind of people will gain the crucial competitive advantage. So in order to achieve that, you need to really eliminate this kind of dependencies or blocking areas. So in order to decoupling the software and hardware and make the software can be really evolved and developed freedom from the hardware. So in AGL, we actually has been continuously working on this virtual for many years. And originally this Wordle actually is coming from the server world, that Wordle net and block, those kind of storage or network has been already well established. And actually in AGL, we not only satisfied with only those kind of devices, but also extended them to be more automotive or embedded related. A lot of multi-media devices and some, for example, automotive-specific devices like CAN has been extended. And we also applied the Wordle into different scenarios, the traditional hypervisor environment, or we even actually explored some architectures during the non-hypervisor environment, which actually because the well-structured Wordle, it doesn't necessary to have hypervisors all the time. We even having the Wordle to connect with different SOCs or multi-ECUs so that you can Let me give some examples on what we have doing for this four aspects we mentioned in the previous page. For example, for the hypervisor environment, we deal with this kind of devices, not only for the block network, but also GPU, SOM, and this kind of console socket devices. And later on, sensors, view, Bluetooth scan, and camera, those kind of things. And nowadays we will further actually extended some advanced or corner use cases to support all the Wordle front end. Um, so for the Wordle non-hypervisor environment, actually we are trying to remove the hypervisor layer, but to still keep the Wordle front end and back-end architectures, so that you can leverage the same Wordle interfaces from the application point of view. It can always go through the Wordle path, and in the backend you handle with the vendor specific logics. So you actually have the vendor libraries and device drivers underneath the Wordle backend, say the Wordle device, so that from the front end perspective, okay, sorry, this is probably is not VM in this case, but it's more like a user space, namespace or whatever, those kind of things. It can really take the standard approach. And we explored some new opportunities with another expert group in the past that we running the containers above the Wordle and also coordinate the priorities with them. And in this diagram, we can actually show that we established some simple scheduler to coordinate the device access from different containers. And we definitely having the resource management, which allows multi-instance access from applications or containers, and also the priority management for both the homogeneous and heterogeneous devices, which is the same devices, different devices. Same device will have the two song instance from Maker and IVI. That, for example, the Maker need to play the alerts, and the IVI is playing music, and you need to give priority to the alerts. And heterogeneous device priority like CAN and audio, so how you need to prioritize the devices. The third applications which we mentioned in the previous four block is Wordle work for the multi-issues, so that we actually for this we have developed such kind of things called unified HMI, which actually is extended from the Wordle GPU. That the Wordle GPU architecture has front end and back end. We put the front end in the one SoC and put the back end in another SoC, so that you can link these two ECUs to the whole system. In this case, you can actually mapping all this kind of physical displays connected to different ECUs to one virtual display, so that you can really control the graphics any way as you like. So this is exactly the architecture as I've already mentioned. In this case, so what the unified HTML will contribute is that traditionally you can only have the one-on-one relationship from your applications to the displays. So it's a really ad hoc interlinkages. But with this unified HTML, because you consolidate all your physical displays in a big virtual display, that you can actually output the applications from anywhere to anywhere, so that you can freely design and output your layout. The last applications of Vordeo is that we are putting the same Vordeo interfaces to the cloud, so that every applications you develop on the cloud can put on the edge, because this kind of interface are the same. So there is binary parity are the same, so that you can really use the exact same software from cloud to edge. And we definitely in the cloud you don't have those kind of significant peripheral devices. And what we trying to do in the future is that to extend this kind of devices, and with establishing some standard interfaces. For example, this standard simulation interface combined with Vordeo, and also standard message or data buses through DES, and then some simple simulation models, and even some simulation models from ROS2 community and other communities, for example. Okay, I think I'm a little bit running out of time, but very last topic is the future AGL perspective and inter-community connections. And maybe some of you have already visited our demo booth. Is that we are working now in the as a reference platform for SDV. It's called SODIF. So we are trying to integrate every components that we have already developed in the AGL, and also integrated or integrated some powerful things like Zen from other communities. In total, we really want to have a code-first SDV implementation. All these features is either coming from AGL itself, or the other Linux Foundation activities. And we believe more SDV enablers to be integrated in the future. And for this part, I think next session, Kurokawa-san will give more details. So I just to give a short introduction. So one last page is that so definitely with this kind of sophisticated software situations for the automotive, so there is necessary to have more inter-community activities, not only for the activity for the communities listing up here, but also, for example, between Japan and Taiwan, or between Taiwan and the other countries. So I think this is very important that all world can work together to build up this kind of SDV related open source software. And one of the very good committee is AGL, is that because we really fulfill with the code first principle, and we really open for integrate and cooperate with different communities. And thank you. And that's all of my presentation. And I think I can follow up the questions later in the 12:30. Yeah.
Jerry, it's soulful presentation. So time is now time is over. So next is 10 minutes breaking time. So Jerry, please wait. So go to toilet and coffee. It's okay. So, but if everyone have a question, he keep to standing this point and he answer to this question. Have a question? Please raise hand. Yes.
Hi. So it was very well emphasized that this is structured as this like open initiative that anyone is freely able to contribute and to either code or discussion. However, we're talking about an operating system that runs on a car. If you either don't have a car or can't afford to hack the software in your car, how difficult is it to kind of interact with the code and kind of productively contribute to code and discussion?
Oh. So let me try to understand your questions. So you want to ask how it will be. So maybe after, however, could you please pardon again?
Yes. It seems difficult for me to develop code
Okay.
if I don't have access to
Okay,
a
okay,
car
okay,
where I
yes,
could.
yes.
Yeah.
So with this point, actually, this is a headache not only for you but also automotive developers. That sometimes we don't have hardware, we don't have the exact the environment that we need to develop for those kind of hardware. So that's also the important initiatives that different open communities trying to build up virtual systems so that developers can really working remotely without the access to the real automotive hardware. So that's the reason why I also mentioned about that.
Got it. Thank you. Thank you.
Please repeat Chinese to detail the question and I can't answer.
OK 就是好就是刚才的这位先生呢有问到，就是因为有的时候呢尤其是很多的 developer 或者是开发人员，他们是手中是没有这种车用的 hardware 的，没有这种车用的 hardware 的话，他们就是很难去做这样一个开发，然后也很难去做 contribution。然后他想询问在这种情况下是怎么更好的去做这件事情。然后我刚才跟他解释的话，这也是一个为什么现在 open source community 也不止 open source community， 现在整个industry 都在很强调virtual hardware， 或者是比如说在如何 enable 这个automotive software 在这个云端开发。然后这方面的话，在这样的一个环境下呢，今后尤其是这种软体的工程师呢，会更加容易的 access 到这样的一个云端的服务器上的development environment， 然后去做这样的一个开发。Any other questions in either Chinese or English？ 哎，你好。
So first of all, thank you very much for your presentation. It's well informed. And actually, I work for VicOne. VicOne is a automotive cybersecurity company. So my question would rather be, is there any interfaces or is there any predefined entry point where a cybersecurity company can hook into, or do you have a place in your overall architecture where cybersecurity matters?
Okay. I think it's very good questions that, for example, the existing, open source communities that doesn't have enough, interface or implementations regarding this kind of cybersecurity. But we do find a trend that actually more security vendors, even like VicOne. Actually, I think some of your colleagues joined the discussions in SOFI, for example, to giving some ideas on how your solutions can enabling or helping open source software to be more safe or to be more secure. And that's also the importance of the for example, interface standard software like Wordle or Zen or this kind of things that you have a definite target that to make them secure. So I think it's a bi-direction collaborations. One is the community should think how to involve cybersecurity vendors into the ecosystem. On the other hand, is that the cybersecurity vendors also need to consider with the existing standards how we can make this kind of standards more secure.
Or maybe we should join AGL.
Yes, definitely.
Thank you.
Please repeat by Chinese.
Do we need?
So please follow up the question detail of your answer detail in Chinese.
有人需要那个用中文重复一下吗？如果需要的话，就重复一下。是不是能问你？
Okay. Thank you for Jerry. So this session is closing this time. So migrate to next talk. So next speaker is Harunobu Kurokawa from